Okay, so an average value of a function, the way that I think of this is if I gave you a list of numbers and I said, here, average these, you would add them up and then divide by however many you had. So like if I gave you a list of 12 numbers, you would add them all up and then you'd divide by 12. Average value of a function is the exact same idea. The integral adds up all the area. So you would do an integral and leave a little space here. You would do integral from a to b f of x dx. And that's like adding up the list. That's adding up all your rectangles and your Riemann sum, right? That's adding it all together. You just have to divide by the length of the interval. So out front, we put a fraction 1 over b minus a. B minus a would be the length of the interval, that's that distance, and you just divide by that, and that is what makes it an average, okay? Don't confuse this with average rate of change, back from unit 2. Hey guys, what is an average rate of change asking for? You're asked for an average rate of change, what should you find? Good, perfect, guys. That's slope. Average rate of change is slope. Awesome. Average value involves an integral. All right, so just be careful. All right. So we're going to find the average value for each of these. So it's going to be 1 over 3 minus 1. And I know you're like, Ms. Cole, I know what 3 minus 1 is. I know that that's 2. If you want to go ahead and put that, that's totally fine. You just do that step in your head. The only reason I don't is it's satisfying for you when these numbers match. Like it should be 1 over 3 minus 1, integral 1 to 3. Like these numbers should match up, and I just like to make sure that they do. All right, and then the function goes inside of there, dx goes at the end. We're going to do the antiderivative, and just out front, and I'll simplify it in the next step. Out front, there's just going to be this 1/2. So antiderivative for x squared, that's going to be 1/3 x cubed. For 4x, that'll be 2x squared, and we're going to evaluate from 1 to 3. So it is upper boundary minus lower boundary. So we're going to plug in 3 for this whole thing, and then minus plug in 1 for the whole thing. So if we plug in 3, 3 cubed is 27, a third of that is 9. And then 3 squared is 9, double that is 18. Minus, and now we're going to do 1. So plug in 1 to all this. So that'll be 1/2 times a third plus 2. And I think we've simplified enough of these, so I'm going to let us just stop there. That one's kind of crazy with the fractions anyway. All right, so for this one, same thing. It's going to be 1 over pi over 2 minus 0. Integral 0 to pi over 2. Again, I just like making sure that those match. And then cosine of x dx. So out front, you have 1 over pi over 2. When you divide by a fraction, that's the same as multiplying by the reciprocal. So I'm going to just flip that over. So out front, we're going to have 2 over pi. And then I need the antiderivative of cosine, which is going to be sine. Derivative of sine is cosine. And we're going to evaluate from 0 to pi over 2. All right, so plugging in pi over 2, let's pull this out again. We said pi over 2 is up here at the top. So what is sine of pi over 2? What is that going to give us? Ooh, not 0, close though. No one else answered though. You're the only one that answers. Sine of pi over 2, guys. Yeah, good, 1. Sine is going to be the y value. So that will be 1. All right, so if we plug in pi over 2, sine of pi over 2 is 1. Minus, all right, now I need sine of 0. 0 pi is right here, means you haven't rotated anywhere. So what is sine of 0? Good, that one's going to be 0. And I just always remember sine of 0 is 0. That graph starts at the origin. It has the point 0, 0 on it. So anyway, this whole part's going to be 0, so that's gone. And so your answer is just 2 over pi. All right, so for this one, same thing. It's going to be 1 over 4 minus 1, integral from 1 to 4, 1 over 2x dx. So this fraction out front would be a 1/3. I'm going to also bring this 1/2 out. So if I have a 1/3 times a 1/2, that's going to be a 1/6. And then in here, I'll just have 1 over x dx. So that antiderivative is ln. And we're going to evaluate from 1 to 4. So that is going to be 1/6 ln of 4 minus 1/6 ln of 1. But hey guys, what's ln of 1? Yeah, good, that's 0. And so your answer is just this part, whatever that is. I don't know what that decimal is off the top of my head. All right, so this one says we're going to use this graph for 4, 5, 6, and 7. So these ones right here. So I have these ones going with this graph, and then I have 8 and 9 going with this graph. So we are told this region A, so this first bump here, is worth 2.3. So that has an area of 2.3. And then we're told the integral from -3 to 7, so that's the whole thing, equals -7.8. So if we add these together, we should get -7.8. So that would be 2.3 plus whatever b is worth is going to be -7.8. If we add these together, that should be that whole integral from beginning to end, from -3 to 7. So we would subtract over this 2.3. And so b is going to be worth, what is that, -10.1. Does that make sense that that's negative? Does that make sense that that came out to a negative answer? Like, are we surprised by that? Yeah, that's good because it's, I like that, yup, because it's below sea level. All right, good. So it's good that that came out negative. If it came out positive, we would have been like, oh, I think there's a problem here. All right, so this is 2.3, this is -10.1. We're going to use that to answer the question. So integral from 1 to 7, so from here to here is -10.1. And then from 1 to -3, so that's from here to here. Thoughts on that one? Because it won't be 2.3, what will it be? If we go from 1 to -3. Yeah, good, nice job, guys. Because we're going backwards, so -2.3. This one, we want to go from -3 to 7, so that's the whole thing, but we want to treat them both like they're positive. So it'll be 2.3 plus 10.1, so that's going to be 12.4. And then lastly, we're going to do average value from -3 to 7. Okay, so setting this up, it'll be 1 over 7 minus -3. So that'll be 7 plus 3. Integral from -3 to 7 f of x dx. And again, I think it's just satisfying if these numbers match. So I always write that out. So this is going to be 1/10 times whatever this integral is. And this one, they actually gave us, you can get it from the graph if you wanted, but this one, they gave us way back here in the beginning. Integral from -3 to 7 was -7.8. So 1/10 times -7.8. All right, and then these two questions, we're going to use this graph. Now we're going to have to break this all up and find all the areas of these. So these first three are trapezoids, and they're all on their sides. So remember, the height is this distance. So the height is going to be 1 for all these. This looks like a skyline or something. It looks like a village with buildings in it. I don't know. That's what I see when I look at that. All right, so let's do this this first area. It is a trapezoid. So 1/2 times the height, and then add the bases together. So this base is 3. This base is 1. So 3 plus 1 is 4, half of that is 2. Now these two are going to be the same. So once I do one, the other one's going to be the same. So 1/2 height, And then the bases are 1 plus 2. So 1 plus 2 is 3, and then halves. So 3 halves for each of those. And then this is a rectangle, base times height. So 3 times 1 is 3. So those are all of the areas. And then we can use that to answer the question. So integral from 1 to 7. So that's the whole thing. We want to add all of that up. So 2 plus 3 halves plus 3 halves plus 3. So let's see, this is 1.5 and this is 1.5. Together that would be 3. Plus 3 is 6, plus 2 is 8. So that total for the whole thing is going to be 8. And then lastly, the average value. So it'll be 1 over 7 minus 1 integral 1 to 7 f of x dx. So the fraction out front will be a 1/6. And we literally just did this. That integral from 1 to 7 f of x dx, we said that that answer was 8. So this is 1/6 times 8, which is 8/6, which would be 4/3.